Welcome, dear friends, to the Rapid Roundup session on Information System for Managers. Information systems, as you all know, are the backbone of today's organization. Can you think of any organization for the matter? Just think of your local shop near you. I do not think many people would have seen even even your nearby grocery shop not having at least one computer, right? There definitely they will be having at least a GPay sticker will be there, right? Even the street side vendors are using GPay. Correct? So what is happening there? What are they making use of? They are making use of information systems. They are making use of technology. So we can definitely say the information system, or IS for short, is the backbone of today's organization. And how does it become the backbone? By facilitating communication. It can streamline processes, right? And it can provide, if as the organization grows, as there are managers who know stuff come into picture, then they also gather the data that they have with us and use that data to provide valuable insights for appropriate decision making. So as future managers, it becomes imperative, it becomes very important that we have to understand this power that information systems can give for our businesses, and not just realize that, but also understand how we can harness that power of information system so that our organizations, whatever business that we are serving, can stay competitive in this increasingly digital world. So in this course, we are going to look into the various aspects of this information system, starting from the basic foundational concepts to the emerging technologies, and how this information system has, or you can say, what is the strategic role that these information systems play in driving an organization towards innovation and growth. So if you are new to this channel, I am Anu. I will be your guide and facilitator for this course. I run a small but growing YouTube channel named Anu's Classroom that is aimed at helping IGNOU students like you overcome the limitations of distance learning. How do I do that? By providing quality content to the best of my ability. My goal here is to assist you not just in passing your exams with good grades, but also helping you understand the concepts thoroughly so that you become better managers of tomorrow. So our roadmap for this particular course on information systems for managers is divided into 4 blocks, and in total we have to learn 15 units. Okay, so the first block, we will explore the basics of information technology from a managerial perspective. Maybe you guys are from various backgrounds. Maybe you guys have finished schooling or your graduation long back, right? Especially since this is a distance learning platform, this is a distance learning course. So there is no assumptions here. Maybe you know already what information technology is, what are the basics of computers and information science, but sometimes some people do not know that. So we will be having all the basic from the basic, so that even though you are not aware of anything related to computers other than maybe using your laptop or your mobile phone for your daily tasks, we will make sure that by the end of this course, you are in a better position to analyze information systems and how to make it work for your organization. So the first block, we will have an overview of this computer systems and smart devices, computer softwares and networking technologies, just to give you a touch base or a basic foundation. And then when we are moving to the second block, we will shift our focus to information systems, and there we will look at the various offerings like the management information system, that is MIS, control systems, integrated applications, transaction processing systems, and all those things. Don't let these terms scare you. I'll do my best to make sure that you guys understand the concept behind all these things so that you will be in a better position to learn this course in depth, right? So all these things are basically stuff that information technology, IT, has provided us managers with to make our lives easier. And we'll also look at the economics and the security aspects of these things, okay? And continuing into the third block, we'll be talking about system analysis, basics of computer programming and languages. Don't worry, we are not going to go in depth and teach you how to write Python or how to write Java and things like that, SQL queries, nothing like that. There is no technical stuff involved, but you should know. If somebody from your IT department comes and tells you this and that, you should be able to realize whether that you should be in a position as managers to take appropriate decisions on that, right? So for that, whatever basic understanding is necessary, only that we will be taking up, right? So this is not at all very technical into IT and all. Don't worry, this is not like that. It is easy only, just you have to know how to learn it, that's all, right? So here we will try to form, in the third block, we will try to form a basic understanding about how we can build this information system, how it is being built. Only then you can talk about customizations for your organization, right? Similarly, system analysis and things like that. And in the fourth and final block, we will broaden our knowledge on the various support systems for management decisions like database resource management, data warehousing, data mining. These are all emerging concepts actually. Right, and then the emerging trends in IT like artificial intelligence, decision support system, that is nothing but DSS, machine learning, all those things we will touch upon. So I'm very excited to join you all in this learning journey, and I'm sure that together we will gain valuable insights on these various IT offerings for managers and management, which empowers us to drive success and profitability in our future endeavors, right? I hope you will be sticking with me till the end of this course. We will cover all 15 units. We'll touch upon all 15 units in this one single video, okay? So I hope you will not wander away from this, that you will be rooted in this video itself, right? So with that, before we dive into our discussions, I just want to take a moment out of this out of your time and to ask you to ensure that you have subscribed to Anu's Classroom and you have enabled notifications. Why I am asking this is because by doing so, you can ensure that you will never miss an update from me. And this way, you can fully utilize all the resources that I provide to support your journey towards earning your postgraduate degree from IGNOU. So again, I am here for you. I'm making this video so that your learning journey becomes easier. So in that process, definitely you will have your own questions, doubts, maybe you will have some suggestions or comments, right? So feel free to leave all those comments or questions or suggestions below in the comment box, or you can drop me a mail. That is also fine, right? I'm here to support you. So don't hesitate to ask anything. That is all, right? But just remember, keep those comments professional, like you would do in your future managerial roles, right? The way you communicate in this community, we are a community. Anu's Classroom is a community. So the way you communicate in this community, I want you guys to do so reflecting on how you will communicate if you were a manager. And that not just any manager. Think of yourself as if you were a CEO or a CFO or a COO or CTO. And the top management, if you were that, how would you communicate with others? Right? I want your communication to reflect that over here in our community so that it will become a practice for you also, right? So let's start, right? So information technology. In today's digital age, we all know, we said earlier also that it is the backbone of organizational efficiency. And also, not just information systems, there is also one more thing that is driving organizations today in the digital world. That is electronic commerce. Flipkart, Amazon, right? Nykaa or PayPal, GPay. All these things are various forms and formats of electronic commerce. So this particular information technology and overview, we will be covering on both this information systems, and we will touch a little bit upon electronic commerce so that you guys have a basic understanding of both these concepts, right? So first, let us delve into the fundamental concepts of information systems, that is IS in short. So wherever you are seeing this IS, please understand this is short for information systems. Okay. So let us dive into the fundamental concepts of that, and let us explore the various ways in which it shapes our modern business landscape. At the heart of an information system lies a few major things. What are they? Hardware, software, data, procedures, and people. When information system is the backbone of an organization, of a business, these 5 things are the backbone of that information system. Right? So these 5 things, hardware, software, data, procedures, and people, they work together to collect, to process, store, and disseminate data. Disseminate data means disperse, give out, right? Spread data. Ultimately, this is what empowers decision making and control within an organization. So what is hardware? Hardware is the tangible devices. Tangible meaning what you can touch, like computers, servers, things like that. Your mouse, your keyboard, everything is tangible. If you can touch it, it is hardware. Now, the second part is software. What is software? Software is what we cannot touch, which is driving programs, right? Programs which drives the hardware to work. Like you can, if our body is the hardware, our thoughts, our emotions, all those things are our software. The behavior, our responses to stimuli, these are all our softwares. So something like that is there in our systems also, in our information system also. Microsoft Word, Excel, Chrome, VLC player, right? All these things are softwares. Now, The third part is data. Without data, neither hardware nor software is going to be of any use, right? What is data? Data is that raw material which which helps these information systems to form the procedures and all the things, right? So that is the basic raw material. This is the major part. Data is information. Basically, it is information. Without information, can we take a decision? No. Then how can you expect a computer hardware or computer information system to take a decision? No, right? Information. Basically, you can, in simple terms, if I were to tell you what is data, it is nothing but information. Okay, so that is the raw material. And then comes the procedures. What are procedures? They are a set of rules of engagement. And people, they are the skilled operators that bring the system to life. You have a computer with MS Excel sitting there in your office. Is it going to give out worksheets for you? Is it going to churn out invoices for you? No, right? There should be somebody sitting over there creating stuff, right? Feeding it data, asking it to print. There should be something there, right? So that is people, the skilled operators who bring this information system to life. So those are the major components of information system, and the impact this information system has on business is profound as well as multifaceted. Multifaceted meaning having multiple faces. Multifaceted face, right? Having multi-face, many faces. So firstly, we can say information system can boost an organization's competitive edge by helping it enhance its market share, facilitating better negotiations with suppliers and things like that. Secondly, you can say it fuels the productivity enhancements, can help in streamlining processes, redefine quality standards. All these things are all impact of information systems on a business. Then coming to the management information system, that is nothing but MIS, and the decision support system, DSS. These help this management information system as well as decision support system. We will learn about both of these in detail in the coming units. Okay, in this session itself we will learn. After a while we will start looking at these in depth, but right now just understand there are these two things called management information system and decision support system, which equips leaders with crucial insights and aids them in the strategic decision making. Also, information system enables lightning fast computations, correct? If I ask you to divide or multiply, say 3, 4, 5, 6, 7, 8 into 3, 4, 5, 6, 7, 8, how many of you can answer? Not many of us are Shakuntala Devis, right? We need a help of a calculator at least. If the calculator is not at hand, we will open our calculator in the notepad. Sorry, in our laptop or in our phone, right? So, it equips leaders with lightning fast computations, seamless communications, efficient data storage, automation of tasks. All these things are pivotal for staying agile in today's dynamic market. So what is agile? Have you heard of this word? Agile. I just used this word right now. Agile, have you heard? If you have not heard, then let me break the ice for you. Agile is a methodology, is a method of project management which involves breaking the large projects into smaller phases. Okay, and we will pick up each phase one by one and we will tackle them. That is agile methodology. More or less like systems development life cycle, SDLC, you can think of as agile methodology. Okay, a systems development life cycle we will learn later on in this session itself. We will learn. So don't worry about any of these things. Okay. So the reason why I am explaining on these newer terms to you is because since the main language I am using is English, so that I can reach most of you guys from Jammu from Kashmir say Kanyakumari, I can reach. That is the reason why I am using English. But at the same time, I know many of you may not be very proficient in English, but I want you guys to improve your vocabulary. That is why I am doing this. Okay. So where were we? Yeah, agile, right? Yeah, agile. Yeah, so moreover, IS empowers proactive problem solving also. And all these things enable organizations to anticipate as well as address challenges before they get escalated, before they go out of hand. And IS is also, IS means information system. It is also the cornerstone for organizational structure and strategy, providing the framework for responsive action amidst external as well as internal pressure. So these are the way information systems impact an organization. The internet, which is a global network of networks, is what serves as the lifeblood of modern connectivity, correct? It is because of internet, it is because of that I am able to speak to you. You are able to communicate with me. Otherwise, I stay in a very remote part of Kerala, a very small remote village in Kerala, right? How will I reach you guys? that if it were not for internet, there wouldn't have been a YouTube, there wouldn't have been such a platform for us, right? So the internet, which is the internet, is a net is short for network. Okay, internet, right? Internet, that net is short for network. So it is a global network of many networks. So it is like a network of networks, which is serving as the lifeblood of modern connectivity. It's protocol, TCP IP, all these things. TCP IP means transaction control protocol, or IP is internet protocol. This TCP IP, don't worry, you don't have to learn in depth about all these things, but you need to understand. So protocol is nothing but a set of rules which have been defined by the people who created this internet. Okay, this is what underpins a seamless communication across diverse computing resources worldwide, from facilitating fast and cost-effective communication channels to serving as a conduit. Conduit means as a, what you can say, conduit is also a channel only, as a channel. So I hope you got one more new word here, right? It serves as a channel. What serves as a channel? This internet. It serves as a channel for data transfer, email, social networking, all these things. The internet, it transcends, it goes beyond our physical boundaries, fostering collaboration and innovation on a global scale. If it were not for the internet, do you think we would have been able to get past this COVID-19 thing with this much ease? No, correct. So that is internet, which we all know. There is something else. Again, a different type of network, that is called the intranet. Intranet on the other hand. So internet is what we all use, we are all familiar with. Now, there is another thing called intranet. That is private networks, which is confined within an organization's walls. So, like for example, if in your organization, all the computers within your organization, in your office building, they might be connected, correct? So that is an example of intranet. Outside the organization, from your computer, from your personal computer, from your home, if you try to connect to that, it might not be possible to connect to, correct? If you are working in an organization, you will understand it much better. Otherwise, just understand this. So within a building or within that office space, for its own employees, businesses create networks so that their computers, their systems can seamlessly interconnect without having any security issues. The main reason here is they do not want their data to be hacked. They do not want their network to be hacked. So if you are in the internet, there are chances that it could get hacked. But if it is a private network, then that chance becomes more slim, right? It becomes much more lesser. So that is intranet. It is private networks, right? They also leverage the protocols like TCP IP protocols and all, they also employ for secure internal information sharing and operational systems. It's just that it is not connected to the wider area network. So like this, so these are the basic two main types of networking that we need to know, internet and intranet. There are others also like LAN, which is local area network, or MAN, which is metropolitan area network. Then we have WAN, WAN, wide area networks. So those all are different things. The only difference between all these things is the scope, the area, or the number of computers, in which locality, in which geography, all these things, how they are interconnected. Only those are the major things that differ, and all minute things, that is okay. Okay. So at least you should basically know about internet and intranet. That is why, since this is a rapid roundup session and we are not going in depth into each and every point, if I do that, we will not be able to cover all these 15 units in this short time frame. This is very short time frame, right? So that is why we are restricting in this rapid roundup section. I am restricting our discussion to these two major types of network. Okay. Now let us talk about the next thing. So we saw about information systems. These are the major things in information system. Let us talk about the electronic commerce, right, which is also a revolutionary process of buying and selling goods and services electronically. This electronic commerce leverages the internet's vast reach and enables businesses to go beyond their geographic limitations and operate on a global scale. From marketing and advertising to customer support and payments, this electronic commerce drives efficiency. It reduces the cost and enhances customer service, all the while expanding the horizons of business operations. Like, you know, right? You yourself might be aware. Now all we need is a website, and I can start a shop from my own bedroom. I don't need to go rent a shop to start a business. All I need is a website, correct? So that is the power of electronic commerce, which is also part of information systems and how it is helping businesses grow. So within the realm of this information system, various types cater to diverse organizational needs. Like for example, the transaction processing system, that is TPS. It helps to record the processes, or you can say day-to-day transactions, right? I bought this, I spent this much on this thing, or so and so person bought from me something like this. That this is a very small example of transaction processing system, what I'm saying. But yeah, so all the day-to-day transactions can be recorded and processed in the transaction processing system. Similarly, MIS, that is management information system, it helps to filter out the data into actionable insights for management. Similarly, decision support system, or DSS, it empowers decision makers with interactive tools, while there is another thing called the executive information system. So TPS, MIS, DSS, Executive Information System, or EIS, it provides strategic information to the top level executives. Similarly, there is something called as expert systems, or ES, which lend domain specific expertise to people. So a lot of experts in a particular domain, like say for example biomedical, or any medical field you think, there are a lot of doctors, there are a lot of specialists. Now what if I go to each of those doctors and collect all the information or all the knowledge they have and put it in one system, and then that system will act as if I am consulting with those 100 doctors at the same time. So all those 100 doctors, all their knowledge into one system, right? So that is an example of expert systems, right? And then there is something called as office automation system, or OAS, which streamlines our routine tasks. And then we have enterprise resource planning system, which integrates and disparates business processes into cohesive whole, which also all these things help to drive operational efficiency and synergy. Synergy, what is synergy? I want you guys to find out and comment below what is synergy. Okay, I don't want you guys to see. This is a check whether you are sleeping or not in this, right? So if you're not sleeping, you would have heard this. Go and comment what is synergy. Find out and comment in the comment section below. Okay, so synergy between this transaction processing system, that is TPS, and management information system, MIS, this is what epitomizes the symbiotic relationship within an organization's information system. TPS serves as the data powerhouse and captures the process and processes the raw information, whereas our MIS, it transforms this raw data into actionable intelligence, equipping our management with the insights that are needed for an informed decision making. And in the realm of electronic commerce, the advantages are again manifold. We have reduced inventories, overhead costs, we have a much more streamlined process, expanded market reach, enhanced customer service. All these things are just a few benefits that electronic commerce can bring to the table. However, the thing to note here is that success in e-commerce hinges not merely on the technological prowess, but on the formulation of a very sound e-business model that is tailored to the digital landscape. And central to this decision-making process in modern organizations is the computer-aided decision support system, that is CADS. And by providing decision makers with relevant information and analytical tools, this CADS, or computer-aided decision support system, can empower them to navigate the complex and unstructured problems, fostering a very informed decision making as well as strategic planning. So in essence, information system and electronic commerce, these are all, you can say, think of them as twin engines that are propelling businesses into the digital frontier. And by optimizing operations to expand the market reach, their transformative power of IS as well as electronic commerce is what fuels innovation and ushers a new era of unprecedented connectivity and efficiency for any organization in today's world. Now, in the world of computing, it is important that we understand the intricate components that form the backbone of a computer system. So let us dive into the fundamental elements that shape the functionality and operation of modern computers. At the very core of every computer system lies a large number of components, and each of those serve a crucial role in the data processing and communication. There is no one component in computer system which is serving no purpose. In human body, there is pancreas. Not much use of that pancreas right now, but if it disrupts, it's a big problem, headache, right? Like that, but there is no component like that for computers. Okay, so last time we saw previously, a few minutes back, we discussed about the components of information systems. I hope you guys remember, you haven't forgotten. What was that? Hardware, software, data, procedures, and people, right? So let us look at all these things. a little bit more in depth, right? Especially the hardware software part, right? Input devices, output devices, we have storage devices, communication devices, all these things are there, right? So what is this input devices? Input devices are those devices which help us to feed data into the computer, like your keyboard, your mouse, all these things are input devices. It is with the help of those that we give the computer data. Similarly, output device is like the monitor or the printer, your fax machine, all these things are output devices. They help the computer provide us with data, right? They enable the output of data, and this both this input and output devices together is what helps us interact with the computer, right? So that is input and output devices. Then we have any computer will have its storage devices. Somewhere it is stored, right? You have a hard disk, right? In phone you have a small scan disk, right? Small drive disk is also there for you in the phone also. Nowadays most of our phones don't have it. Earlier we used to have, right, separate storage disk we provide, right? You remember CDs were there earlier. Even before that it was floppy. When I was a small kid it was floppy. Then came CDs, right? So all these are storage devices. We store our data in it, like pen drives are there, correct? So we store our data in them. And this storage, if you might have heard, sometimes at least if you have a laptop, at least even if you don't know any other part, sometimes our laptop does not turn on and we take it to the computer repair shop. They might say that the RAM is gone. What is RAM? That is a type of storage device. That is where most of the time the problem happens. Even in my channel, I myself, after starting this YouTube channel, there have been multiple instances where I was not able to post videos because my computer's RAM went, and I have a very old computer for that matter. So there are frequent repairs that happen also, right? Similarly, there is one more component in our computer which is called ROM, read-only memory. But that guy is silent. Not much problems happen with that person. Sorry, that storage device, right? It is the RAM which provides most of the issues, and it is that RAM which helps in the processing also. Like the speed of a computer, it depends upon your RAM, right? So mainly, if you were to divide your storage, classify your storage systems of a computer, you can divide it into primary storage and secondary storage. Primary storage is also known as the main memory, and it plays a pivotal role in temporarily housing data and programs while it is processing. So when you open Microsoft Word or a particular Word document and you are editing, you must understand that it is currently what is happening is that it is residing in your RAM. So the computer creates a copy of it in the RAM, and it is that copy that you are editing. Now, and once you save it, a copy of it goes to your and resides in your ROM. Okay, ROM is read-only memory. So when stuff is stored in RAM, it provides fast access to the information that is required by CPU. And that is why when your RAM capacity is good, you will see that your laptops are performing a little bit more faster, right? So conversely, the secondary storage offers a vast reservoir for storing data and programs over the long term. And devices like the hard disk drive or your SSDs serve as repositories for this large volume of data, ensuring persistence and accessibility beyond the volatile memory. Suppose you did not save your document and your laptop shut down. When you open it, it is gone. Correct? That new additions which you made before hitting that save button, it is gone. But if you save it, what happens is that one copy of it goes into your read-only memory. That is your secondary storage. So even after you power off your laptop and you power it on, even after a month, you will still see that that document is there exactly where you left it, right? That is because when you save it, when you click that save button, what happens is that it goes and resides in your secondary memory. So RAM is volatile. The primary memory is volatile. Once you power it off, it is gone. Okay, but ROM is not volatile. Similarly, we have communication devices which enable computers to connect with one another and exchange data, right? So like from Ethernet cables to wireless adapters, all these communication devices is what facilitates the seamless data transfer and networking capabilities, enabling collaborative workflows and distributed computing paradigms. At the very heart of every computer system, you must understand this, is a brain. And the computer's brain is called as the central processing unit, CPU. It is often likened to the brain of the computer, and comprising this in this central processing unit, just like how you have the cortex, the left side, the right side, the medulla oblongata and all, even if it is your brain, it is having so many small parts is what makes your brain, right? Similarly, the central processing unit also comprises of many parts. Mainly it comprises of the control unit, that is where all the controlling happens. Arithmetic and logical unit, that is where all the arithmetics, the logical processing, all those things happen. And then we have storage unit. So storage is also there in your CPU. So while your CPU is processing, it will have to store things. So going and storing in the RAM itself might be time consuming. Okay, so even before things go to RAM, it is stored in the CPU. Okay, so that is also there. So these are the major 3 parts of your central processing unit, and the CPU is what orchestrates the execution of instructions and coordinates the activities of all the other components of the computer system, just like how our brain controls our hand, our feet, our nose, tongue, everything, right? Just like that, it is the central processing unit which controls your printer, your monitor, your keyboard, your mouse, everything. Okay. So the control unit of your CPU is what initiates and manages all the memory operations, whereas the arithmetic logical unit will perform the mathematical calculations and logical operations that are essential for computation. And the storage registers serve as a high-speed repository for all the data and instructions that are needed by the CPU, ensuring that we have a very efficient processing and execution of tasks. The speed and performance of this computer system is influenced by a multitude of factors. And one of the things that you have to know about is the clock frequency, which is measured in gigahertz. Okay, this clock frequency, if you go to any laptop purchasing site, you know, Dell or HP or anything, and you look at the specifications of the computer, especially in the CPU side and all, you will see this word also, clock frequency, right? So this is the clock frequency is what dictates the rate at which CPU processes instructions. So with higher frequency, with higher clock frequency means you will get faster performance. And additionally, if there is one more thing, whether your CPU is 2 cores or 4 cores or 8 cores, this also, if you want to see all these terms in real life, no, just go to Dell or HP, any site, go pick any laptop from their list of offerings, you will find all these terms listed over there. Okay, so you will see cores. So what is this core, right? So CPU cores and the number of and the availability of cache memory, all these things impact computational throughput and multitasking capability. So the more the number of cores, the more the multi-threading that can happen, so faster the performance is going to be. But as the number of cores increase, what you must realize is the price is also going to be increased, right? So as managers, since we don't have to go to technical stuff of this, I'm just leaving this discussion over here, okay, of cores and cache memory, because it is not necessary for managers to know beyond any of this, right? So the type and speed of storage devices like your hard disk drive, solid state drives, all these things also influence data access and retrieval speeds. That is why from a traditional HDD and SDD, that too there are 2 types. Some like persistent is also there, right? And all these things affect the speed of the computers. Like if you want to see that in action, you have to actually, you know, upgrade an existing HDD computer to SDD. I recently, when my RAM crashed the last time, I told that guy to update my hard disk also, make it SDD. Right? After that, my computer has been performing a bit more faster. Mine is a small 4 GB computer laptop, actually, very old model actually. So it was very much lagging and I was having a hard time making presentations and PPTs and stuff like this for you, you know. It was a very tedious task. Like the computer itself used to take minutes to power on. But when I changed it to solid state device, SDD, the boot disk as well as the HDD, what am I saying? The hard disk as well as the boot disk, both I made it as SDD, but so now it only takes seconds, right? So the thing is that these things matter. These things cost money. So when you are managing for a business and you might have to sign off procurement deals, you must understand all these things and you must be in a position to judge between what is needed and what is not needed. That is why I'm saying all these things to you, okay? So again, similarly, the amount of random access memory, that is RAM, it dictates the system's ability to handle concurrent tasks and store temporary data. That is why these days we have computers that are up to 16 GB or even more you can make. If you're custom building laptops, I'm not sure. If you're custom building PCs, you will have much better capability of RAM. Gaming, if any of you who are listening to this are addicted to games or like to play games, computer games, you would know, right? At least 16 GB of RAM is necessary to play a good decent game, right? At least 8 GB is minimum required, right? So I do a little bit of graphic designing stuff and all. If I have to run Adobe Illustrator or Photoshop, I at least need 8 GB, and for Blender definitely it is 16 GB, right? So all these things, this 8 GB or 16 GB, 32 GB is what we are talking about, is the size of the random access memory. The reason is Photoshop or Illustrator or Blender, these are heavy processing programs. So if they have to work smoothly, it is not going to happen in a 4 GB RAM. Tumbiye kondu kalledipikkiya in Malayalam. That means you are making a dragonfly pick stones. That is a literal translation. So your computer is like the tumbi, okay, the dragonfly. And your RAM is like the tumbi, okay? So, and your Adobe Illustrator or the software is like the kalli, the stone. So if you're making the tumbi, the dragonfly, pick a very large stone which is much larger than its own size, it's not going to be able to pick it up. So you need to know the ideal size, the maximum ideal size that dragonfly can pick up. Only then you can make the most work out of him, right? Before you let it go. Same thing. That is what we are also trying to understand. We are trying to understand the gauge the size of the stone, okay? So within the realm of this memory, primary memory offers the fastest access to data, but the thing is that it is limited in capacity and it is volatile in nature, meaning data is lost when the power is discontinued. Similarly, secondary memory, if I were to say, it provides a larger storage capacity, it is persistent, meaning data will not be lost when the power is shut down, but the thing is, it typically offers a slower access time compared to the primary memory. And how this RAM and ROM differs, why is there a speed difference, is because of how these memory devices are created. Like there are, I'm not sure whether you've heard of this, there are things called capacitors, resistors, and things like that, inductors, all these things are there. And it is with these small things, these are, you can think of them as, this is a resistor, okay? This, if you have studied physics, you would have seen this symbol, right? This is a resistor, this is a capacitor. So these are small things which are the building blocks of any component in your computers, okay? It is a combination of resistor, capacitor and inductor. So and diodes and things like that. So how they are created or how they are combined is what dictates how fast you can access it, whether it is volatile or not, and that is why this difference is there, okay? So the types of primary memory, we were talking about primary memory, I think I'm deviating a lot here, right? The type of primary memories include RAM, that is random access memory. Then we have read-only memory, that is ROM. Each of these serve distinct roles in data processing and storage. So RAM is characterized by the fast access time, but it's volatile. It acts as a temporary workspace for storing data and program instructions. And we have various forms of RAM also, like dynamic random access memory is there, static random access memory is there. All these things offer differing trade-offs in the speed, the cost, the power consumption, all these things, okay? Similarly, ROM, on the other hand, it is secondary storage. It provides non-volatile storage for critical system firmware, boot programs, all these things, ensuring there is system integrity and stability, okay? Secondary memory encompassing technologies like magnetic tapes, disks, they all provide vast storage capacities for long-term data retention. Okay, so RAM and ROM are primary storage. Secondary storage is like your HDDs and SSDs and all. They provide sequential access devices like magnetic tapes. All these things provide long-term data retention. Okay, so your boot disk, that is your ROM. Okay. Then what? Yeah, so all these things are there. Now, there should be a seamless integration between this input devices and output devices into the computer system. That is how you can have a seamless interaction and communication with the internet or with the computer, with the information system and our external world. So for that, we have keyboards, mouse, monitors, printers. All these devices enables users to input data, receive the output and engage in with the digital realm very effortlessly. Plug and play, it's is one more thing. Plug and play meaning you right now, earlier, I don't know whether you are aware or not, earlier if you have to plug even a speaker or even a new mouse to your system, you need to specifically download the drivers. If you wanted to connect a printer, then we will get an installation CD. We used to get an installation CD with the printer and we should first install the driver, then only if you connect the printer it will work. But nowadays nothing like that. You buy a new printer, you plug it into your system, into your laptop using that USB connector, and boom, driver, everything got automatically downloaded and you can start using that printer in no time. right? We don't need to go through a big process of installing the driver or anything like that. It gets automatically installed in the background, and this is what is called plug and play. Okay, it has simplified the peripheral integration, enabling immediate use of USB devices without any complex setup, enhancing our user experience. In computing, various types of computers meet the distinct needs. Like we have workstations which offer high performance, we have microcomputers, personal platforms, personal computers, we have network computers that centralize the processing. Then there is something called as mainframes, which offer large scale processing capabilities. Like bigger banks like SBI and all, they make use of mainframe computers, because the data volume is very large. It is the largest bank of India. Almost every Indian will have at least one account with SBI, right? So understanding all these options is very much crucial for us managers, so that we are able to navigate the digital landscape very easily. So now let us talk about computer software. So software, it serves as a backbone of modern computing, providing all the tools and functionalities that enable users to accomplish all the diverse tasks efficiently. And understanding the various types of software, their functions, and the decision-making process involved in acquiring them is very much essential in navigating the digital landscape. We have two main categories in software, that is system software and application software. System software interfaces with the computer resources and provides services to other programs, including our operating system, hardware drivers, and compilers. Application software, on the other hand, aids users in solving specific computing problems, like offering tools like web browsers or graphic editing software or instant messaging platforms, right? Skype, or what is it, your Chrome, your VLC media player. All these things are examples of application softwares, apps in short, right? At the heart of every computer system lies the operating system. Like for example, some of you guys might be having Windows, some may be having Linux, some may be having using Mac, right? Android is an operating system, right? That is at the heart of any computer software. It is tasked with managing all the hardware resources and facilitating the communication between the computer and applications, allocating system resources, scheduling tasks, monitoring system activities, and providing a user interface. Multitasking is a hallmark feature of operating systems, and it enables users to run multiple applications simultaneously, allowing for a very seamless task switching and enhanced productivity, right? You open your system, Microsoft Windows or Linux, whatever it is, gets opened up, and then in one tab you will have Chrome, the other tab you will have a game play, right? And when your parents come, or when somebody comes, you will immediately switch the game tab to Chrome tab, right? We all have done that. I have also done that when I was studying. The moment my mother comes, I'll switch tabs, right? We all might have done it. Have you done it, or have you not done it? Am I the only person who has done it? Right? So that is what multitasking. And if our computers were not able to multitask, we will also not be able to multitask, correct? So that is task switching. So time sharing technique is also there, which is an extended capability of operating system which enables multiple users to utilize a computer system concurrently by dividing CPU processing time into small slices. Language translators like compilers and interpreters are also there. They play a pivotal role in converting all the high-level programming language code into machine language code. So these are things which you don't actually have to go in depth, but you need to know about that, right? There are things like compilers and interpreters. Like, see, we are seeing in your screen right now, you are seeing plain English language and you are hearing me speak English, right? But do you think so our computer understands English? Is it because our computer understands English that it is able to do this? No. Computers only understand ones and zeros, that is on, off. Because everything is electronic and everything inside the computer is binary, on, off. Right? It only understands one language, on, off, on, off. Why? Because it is an electronic device. Just like a bulb has only two states, right? On, off. Similarly, everything inside the computer only has on and off. But there are many computers, right? You can think of them as if you light 100 bulbs, there are how many possibilities of on, off will be there, right? First bulb on, second bulb off, third bulb on, fourth bulb off. Like that, how many combinations can you make? Multiple, right? So just imagine there are more than 100, definitely millions and millions of such small components are there in your computer. So just imagine how many combinations can you make, and each of those combinations mean a different thing for the computer. So that is binary language. So anything we write, anything the computer shows us has to be ultimately converted into this on off binary language for the computer to understand. The computer only understands that, right? But so we are saying English or I'm saying Malayalam to the computer. How does the computer understand that? There has to be somebody, there has to be a translator to translate what I'm saying to the computer. That translation is done by compilers and interpreters. So these are also two softwares which play a very pivotal role in converting this high level code or high level language, whatever we are saying, into the machine understandable language. Compilers generate object code from the entire source code at once, whereas interpreters execute source code line by line. So the difference between this compiler and interpreter is this. A compiler will wait for you to finish your whole speech and then it is going to convert the entire speech in one go and tell to the computer. Whereas an interpreter will wait for you to finish every single line. And after every line you say, it will tell to the computer, see, this girl is saying this. After that, it will again wait for you to say something. Once you say, it will again say, see, this is what she's saying now. Like that. Line by line interpreter. But entire bulk at one go is a compiler. That is the only difference. Both of them are translators. Okay. So each approach offers distinct advantages as well as trade-offs, with compilers prioritizing efficiency, whereas interpreters favoring rapid translation and platform independence. So depending upon the use case, we will use compilers or interpreters. That is purely technical stuff. Okay. We don't have to go in depth, but at least this much you need to understand what is a compiler and what is an interpreter. Programming languages are again some things which help computers. Using this programming language only, we write system softwares are things. Okay, so programming languages are neither pure English nor are they machine languages, right? You will see English like words and numbers and things like symbols and everything combined together. So it is like you can say an intermediate between your natural language and your computer language. The compiler will take care of converting this programming language into machine readable code. So programming languages have evolved over generations, and each language, as with each generation, have its own unique characteristics and capabilities. The first generation language consisted of machine code. Okay, it was represented in binary form. We had to actually give it ones and zeros, ones and zeros, ones and zeros. That time the machine did not understand even a word of English. But later on, second generation languages came, and mnemonics, that is small short forms, like 2-3 words, like 2-3 letters clubbed together, add, sum, go, like that, it started understanding. Okay, then came third generation language, which resembles English, and it offers ease of use, but definitely it came with a cost of reduced efficiency compared to your machine level language. The fastest language is always ones and zeros, but is it fast for us? No. It is very difficult for us to write in ones and zeros, but that is the fastest because there is no need for any translation, right? If I can speak computer, then it is very easy. Now we are making the computer speak our language, so it is becoming a little bit difficult for us. So there is a very lower reduced efficiency is there, but it is easier for us to program. Fourth generation languages emphasize output formats over procedural details. We have object-oriented languages which enable modular and reusable code structures. Then we have open source software, which presents numerous advantages including cost effectiveness, customizability, enhanced security, community support, interoperability, and decision-making process of acquiring application software involves identifying what your organization needs. So this part, acquiring software, how can we do that? This is the part which is most important when it comes to your day-to-day operations as managers, right? So how do you make the decisions of acquiring application software? You have to understand, you have to identify what the needs of your organization is and determine whether you have to build your own software or whether it will be much more easier if you buy it from somewhere else, and select the appropriate software vendor or the product. Options range from creating the development in-house, creating the software in-house and customizing to contracting software vendors for tailored solutions, or purchasing and off-the-shelf software from the market like Word like Microsoft Office Suite or things like that. So in summary, software encompasses a diverse array of tools and functionalities which underpin modern computing, and understanding these types, the functions and acquisition processes of softwares is very much essential in leveraging the technology to meet organizational and individual needs effectively. Now, networks, right? A network is a system of complex interplay of both the hardware as well as software components of your computer, and this is what enables seamless communication and resource sharing, right? Understanding the various elements and types of networks as well as different architectures of networks is very much essential in navigating the dynamic landscape of modern computing. So first let us look at the hardware components of a network system. We have a server or host computer. This is where data to be transmitted is residing. Then we have client. Client is the receiving computer at the other end of the transmission system. We have something called as a network interface card, NIC, which connects the computers to the network via a cable. Okay, then we have a circuit. This is the pathway. It could be a copper wire or an optical fiber through which the data actually travels, right? It is like the road of the data. Software components of a network system include the network operating system, which is an integral part of a network facilitating communication and resource sharing. We have protocols which govern the rules and conventions like OSI model or TCP/IP. This TCP/IP is a suite of protocols with application network, data link and physical layer protocols. Then what are the various types of network? In the first module, when we were talking about the overview of information system, we saw two main types, right? Internet and intranet. And there I said there are other types of networks also called local area networks or LANs, which connects computers within the same building or at least a few kilometers apart max. Then we have metropolitan area network or MAN, which connects computers in the same city or a metropolitan area. We have wide area networks or WANs, which connects computers in different cities or even countries. We have storage area network or SAN, which is a high speed network providing block level access to data storage. We have wireless local area networks or WLAN, which utilizes wireless technology for this device connections. We have VPNs. Definitely you might have heard of VPNs, right? Virtual private networks, which are secure networks connecting remote users or sites over the internet. Then we also have intranet, right? Private network using internet technologies for internal information sharing. We have extranet, which is again another type of private network using internet technologies for external information sharing. Now, if you are to distinguish between these network types, say for example, how can you distinguish between LAN and MAN? It is based on the geographical coverage. LAN is for smaller areas, whereas MAN is much more wider area for metropolitan regions. Similarly, if you were to distinguish between WAN and SWAN, that is statewide area network. WAN is wide area network, SWAN is statewide area network. Okay, so here the scope and purpose differs. With WAN, it connects cities or countries, whereas SWAN is statewide area network, is focused on state level governance. Internet and intranet we have already seen. Okay, internet is global public network connecting millions of devices, whereas intranet is private network within an organization that is accessible only to those authorized users. So what are the advantages of these networks? Definitely communication, right? It facilitates a very efficient communication between individuals and organizations. Resource sharing is another advantage. It enables the sharing of devices, thus reducing the cost and improving efficiency. Like for example, if all the computers are connected via intranet to a particular printer, then with that one printer, maybe all the people in that one floor just need one printer. Otherwise, or each computer would have needed its own printers, right? But it is because all the computers and the printers are all connected within the same intranet is why we are able to share that printer. Similarly, collaboration. It supports teamwork and productivity through a multitude of collaborative tools. We have access to information. It provides access to vast information resources and aids research and decision making. Cost savings. It reduces cost by sharing resources and eliminating the need for physical infrastructure. Scalability. Easy to scale and adapt to the changing business requirements. So, okay, now let us talk about this TCP/IP protocol suite. TCP is short for Transmission Control Protocol. IP is Internet Protocol. Okay, so TCP/IP. It has four layers, mainly application, transport, internet, and network access. And the key protocols in TCP/IP protocol suite includes definitely TCP/IP. Then there is something called as UDP, ARP, and DNS. Now we also have to know about client-server versus cloud architectures when you are talking about networking technology. So client-server architecture serves in the client-server architecture, the server stores the data. Application software will run on client computers. Okay. Cloud architecture, the resources are pooled through virtualization and are shared across a network. Client-server is cooperative, scalable, and resilient, whereas cloud is highly scalable, distributed, and resilient. So in summary, Navigating this network system involves understanding all the intricate interplay between the hardware and software components and recognizing the diverse types of networks and distinguishing between the architectural models such as client server or cloud. And these insights is what empowers individuals and organizations to harness the full potential of networked computing in digital era. Now let us break down management information system, that is MIS, and how they function within an organization. So MIS is like the behind the scenes wizard, magician, providing managers with the tools they need to organize, evaluate and manage the different departments of an organization effectively. So the key features include decision making support. That is, MIS offers information at all levels of an organization to help with the decision making. Similarly, data handling. It helps to build it is built to handle large volumes of data and information. It can be tailored, this MIS can be tailored to suit the specific needs of an organization. That means it is very much flexible. Integration, it is designed to work seamlessly with other systems of an organization. Similarly, MIS has robust security measures also to prevent any unauthorized access. So now let us see how this MIS supports the various functions that are there within the organization. So first function is planning. How does MIS help with planning? It provides data on the past performance as well as the current trends to the managers, thus supporting their planning efforts. It helps to organize data as well as information in a very accessible format. It provides insights into employee performance as well as availability. Similarly, it offers data on the effectiveness of the current strategies and initiatives, helping with directing. It helps keep tabs on ongoing projects and initiatives, helping with coordination. It provides feedback on strategy effectiveness as well as generates reports on departmental and overall performance. It also helps with budgeting by offering data for budgeting based on the past performances and trends. Now let us look at the two major frameworks of decision making, that is Simon's decision making framework. First, let us look at Simon's model of decision making. It breaks down decision making into three stages, that is intelligence, design and choice. So how it works? Intelligence is where decision maker identifies a problem or an opportunity. In the design phase, they explore all the available alternatives to address the issue, and in choice, they finally select an alternative to pursue. And often it is based on the feasibility or the cost benefit analysis that they finalize on the choice. MIS plays a crucial role here by providing support at each stage. It helps identify the problems and opportunities and develop alternative solutions and evaluate the feasibility and cost effectiveness. Now, if you are to move on to MIS design, SANI outlines very key determinants like opportunities and risk, company strategy, company structure, management and decision making process, the available technology, available information sources, all these things. And when designing MIS, it is very much essential to align with the organization's structure, task and power centers. This ensures that the system meets the organization's information needs very much effectively. Now let us talk about the relationship between organizations and information systems. It is definitely a two-way street. Organizations provide data to the information system, which it will process and make into useful information for decision making. In turn, the system will support the organization with tools to manage data effectively. The purpose of an information system is to provide organizations with the tools they need to manage and process data efficiently. It collects, it stores and processes and distributes data to support decision making at all levels. So what are the benefits of this information system, this management information system? It improves decision making, it increases efficiency, improves communication, as well as it helps in better customer service and therefore provides a competitive advantage. But remember, while information systems are powerful tools, they are only a foundation for human judgment, insight and creativity. They provide us with data, but you should understand that it is up to us to interpret and act on that data effectively. So finally, let us touch on the programmed decision making. Programmed decisions are repetitive and routine decisions which are often handled by automated systems like MIS. They streamline the decision making process, but they can also lead to an over-reliance on automated systems if they are not managed carefully. It is very crucial to strike a balance between this automated and human decision making to ensure there is optimal organizational performance. Of course, Regular controls and audits are also very much essential to maintain the security and effectiveness of information systems. These measures help protect data and ensure that systems are operating as intended. So, data. You can think of data as, I said, raw material, right? It is just the facts and figures which are collected and stored. But when we process and organize that data and give it context and meaning, then that data becomes information. So, while data is unorganized and does not mean much of its own, information is highly organized and meaningful. Let us talk about what are the key characteristics of this information. We want information to be accurate, it has to be complete, relevant, timely, accessible, reliable, verifiable, and simple to understand. At the same time, it has to be secure. So, why do we need this information in organizations? Well, it is very much crucial for decision making, problem solving, planning, and controlling. Plus, it improves the communication, coordination, and collaboration among different departments as well as stakeholders. Ultimately, the thing is that having the right information at the right time gives organizations a competitive advantage or a competitive edge by helping them respond quickly and effectively to the changes in market and environment. Assessing this value of information is very much essential. Not all information has the same value. So how do we assess the value? We can do this in several ways. Like cost benefit analysis can be done, which compares the cost of acquiring and using this information to the benefits it provides. Similarly, return on investment ROI measures the additional profits which we can generate as a percentage of the investment in this information system technology. We can also look at market share, the growth, customer awareness, and satisfaction. Tangible benefits like increased sales are very easy for us to quantify, whereas intangible benefits like improved customer satisfaction and things like that could be a bit tricky to measure. Okay, but in the end, it is about weighing the cost and benefits and considering how information contributes to organizational goals. Now let us dive into the data life cycle, that is from creation to disposal. So data goes through several stages. So we can start with the data generation, that is creation. Then once the data is created, it is getting manipulated. It gets transmitted, stored somewhere. Sometimes it is retrieved, archived, and eventually at one point it will be purged or destroyed. Destruction or purging of this data records is very crucial to end the life of that data. It is all about managing data accurately, securely, and responsibly throughout its journey. Now, on to the success or failure of an information system. Success factors include having clear objectives, a well-defined project plan, adequate resources, and user-friendly systems. Conversely, poor planning or lack of user involvement or inadequate resources can lead to failure. Plus, changes in the goals or the environment can throw a wrench in the works also. Ultimately, the success or failure of information systems depends on a mix of technical, organizational, and human factors. Planning carefully involving users and continuous monitoring are key to ensuring an information system meets the organization's needs as well as goals. Privacy is a very big ethical concern in today's digital world. Organizations must be transparent about the data they are collecting and sharing and obtain consent from individuals. So this is one thing which is very important when it comes to your research analysis also. We will be collecting a lot of data. You should make sure that whatever data you are collecting will not be used for anything else, will not be stolen from you, because in that case you will be in a big legal trouble heap, right? We have legislations to make sure it is not misused, like Right to Information Act ensures individuals have the right to know what information is collected about them and how it is being used, and protecting privacy and confidentiality is very much crucial for maintaining trust and avoiding legal as well as ethical consequences for our businesses. Disasters are something which we cannot avoid, so no organization in the world is immune to any kind of disasters, be it natural or man-made. So we need to have a disaster recovery plan. It is very essential for organizations to protect their computer resources. From natural calamities to human errors, there are various threats which can wreak havoc in our information systems. A solid disaster recovery plan will ensure that there is quick recovery and resumption of normal operations. It includes procedures for data backup, system restoration, and ensuring critical functions can continue even in the face of disaster. Cybersecurity is another crucial factor that we need to be aware of. It is all about protecting systems, networks, devices, and data from cyber attacks. It is crucial to have robust measures in place like antivirus software or regular updates, firewalls, and data backups. All these things to ensure our data is not prone to any cyber crimes like fraud or phishing or ransomware attacks, which are all on the rise, right? So, cybersecurity is very important now more than ever. So following the best practices and standards can help our organizations to stay one step ahead of these cyber threats. Finally, let us talk about computerized personal information system, okay, PIS. This is a system which helps manage the human resources of an organization more efficiently by automating all the administrative tasks and providing real-time access to employee data for decision making and ensuring compliance with legal and regulatory requirements. A PIS, that is Personnel Information System, streamlines the HR processes and improves the decision making and ensures compliance, contributing to more efficient and effective management of human resources. So these are major topics that we have to be aware of when we are talking about the safety and economics of information systems. Now let us move ahead to the next topic. That is transaction processing systems, decision support systems, and EIS, right? Information systems, we all know, are vital for making business decisions because they provide the necessary data and insights that are needed for effective decision making. These systems collect, store, process, and distribute information to relevant stakeholders, enabling businesses to analyze the market trends or customer behavior or any other critical data. And by enhancing communication and collaboration among different departments, the information systems contribute to better decision making processes. Let us break down this difference between data, information, and knowledge, right? So that we can know a little bit more about how these various systems work. So what is data? It is the raw material. It is the unorganized facts and figures we collect and store. And when we process and organize that data, it becomes information, which is meaningful and useful. But knowledge goes one more step further. It is the understanding and insights which we gain from information that allows us to solve problems or create new opportunities. That is knowledge. Visiting organizations to identify their information systems is a very smart approach, so that once identified, we have various ways to improve these systems and ensuring alignment with organizational goals, enhancing security and reliability, and making systems scalable and adaptable to the changing needs are key improvement areas. In production management, human resource development, marketing, several computerized information systems are used, which includes HR information systems for human resource department, MIS, that is management information systems for marketing, TPS is transaction processing systems for various functions, DSS, that is decision support system for analytical support, and EIS is executive information system for executive decision making. These systems streamline operations and support efficient management practices. Transaction processing systems are foundational in information systems development. They handle daily business transactions and data processing, providing crucial data for decision making, and their automated updating and quick query capabilities along with network distribution make them essential for effective business management. Analytical methods like ratio trend analysis or work analysis, cost benefit analysis, all these things play vital roles in human resource management module development. These methods ensure that human resource programs are effective, efficient, and aligned with the organization's goals. Similarly, coming to the Executive Information System, EIS, and Decision Support System, DSS, they serve different purposes in decision making. EIS provides very high-level information for strategic decisions, whereas DSS offers analytical support for specific business problems, highlighting the need for both in decision-making process. Group Decision Support, GDSS, that is another type of decision support system which facilitates collaborative decision making through specialized softwares and tools like platforms like Zoom or Google Meet enable this group meetings over the internet and enhances the brainstorming and voting process. Similarly, social media can significantly support decision making by providing insights into customer preferences or market trends, competitor analysis activities. But however, It is very crucial to analyze the social media data along with other sources and be mindful of the biases and limitations. You should not take only social media data and make any of your decisions. Integrated software applications bring together various tools and functionalities into a single cohesive package. That is why it is called integrated. Okay, in today's fast-paced environment where businesses face numerous challenges, these integrated applications can become a true game changer. So how these applications can address this technology related challenges that businesses might not even realize they are having is what we are going to discuss now. You can think of it like having a cluttered toolbox. You might have all the tools that you need, but if they are scattered and they are disorganized, then you will not be able to find it. It will not be as effective as an organized toolbox, right? So this integrated software applications tidy up that toolbox and bring everything together in one place in a very organized manner. Why is this important? Because without addressing this challenge, businesses can suffer from very decreased efficiency, increased cost, and reduced competitiveness. Imagine you're trying to run a race with a rock in your shoe. It is going to slow you down, right? And it is going to make it very hard for you to keep up with the competition. So integrated software application acts like that turbo boost there. It just doesn't remove that rock from your shoe, but rather it acts as a turbo boost, helping businesses streamline their operations, improve the communication as well as collaboration, and gain better insights into their data. So it is like having a personal assistant who will organize your schedule and keep you informed and helps you make better decisions. Now, let us dive into some of the examples of such applications. So, we have got this enterprise resource planning, that is ERP. Then we have BPR, SEM, CRM, BI, and PMS. Each of these serves a specific purpose, but together they form a very powerful toolkit for businesses. It is like having a set of specialized tools for every task that you might encounter. For instance, this ERP, enterprise resource planning system, it acts as a vast repository of information, helping organizations generate reports that shine a spotlight on every aspect of their business. It is like having a bird's eye view of everything that is happening, allowing you to spot opportunities and address the challenges before they become huge problems. But it is not just about having the right tools. It is also about how you use them. Integrated software applications will enable businesses to plan, to track, and optimize their resources in the most efficient way possible. It is like having a GPS for your business that is guiding you towards success with precision and accuracy. Now let us talk about some of the big players in this integrated software game. You need to be aware of SAP, Oracle, and Microsoft. These are the guys who are like, you can say, the Avengers of the business world, each bringing their own unique strengths to the table. SAP provides cutting-edge technology platforms for everything from database management to machine learning. They have over 238 million cloud users and a very vast portfolio of solutions. So you can think of SAP as the Tony Stark of business world, very innovative, very powerful, and always one step ahead. We have Oracle, which on the other hand offers integrated applications like the Oracle's e-business suite and JD Edwards Enterprise One. They are like Captain America of the group, okay, dependable, versatile, always ready to lend a hand. Then you've got Microsoft with its Dynamic 365 suite of applications. They are like, you can think Black Widow. They're very agile, very adaptable, and they are able to handle anything that comes their way. But here is the thing, while each of these players do bring something unique to the table, they all share a common goal, that is to help businesses thrive in an increasingly competitive landscape. Whether it is streamlining the operations or improving communication or gaining better insights, these integrated software applications are the key to success in today's digital world. The heart of any information system lies in its resources. That is, the people, the hardware, the software, the data. All these things come together to make it tick. So you can think of it as a well-oiled machine with each part playing a crucial role in keeping that system running very smoothly. Let us start with the people resource, okay? So initially also we said, right, IS components we said. So let us first start with the people resource. So these include both the end users as well as the information system specialists. These are the folks who use the system on a day-to-day basis, and the tech team who keep it up and running. So it is like having a team of mechanics and drivers who are working together to keep a race car running at its peak performance. Right? Next up, we have got hardware resources. So these are the machines, the media that power the system, from computers and monitors to printers and storage devices. It is like having a garage that is full of tools and equipments to keep that race car on top condition. Okay, then we have the software resource. These are like the programs that make the magic happen, from operating systems and word processors to payroll and financial management software, everything. It is like having a team of engineers who are designing the engine and fine-tuning the performance of a race car. Last but not least, we have got the data resources. So these are the lifeblood of the system, including everything from raw data to model and knowledge bases. It's like having a treasure trove of all maps and blueprints to help navigate the racetrack and plan the best route to victory. So now that we have got the basics down, let us talk about the various different types of computer-based information systems that are used in businesses. That there is office automation system, which streamline clerical tasks like word processing, email communication. Then there is communication systems, which facilitates collaboration among employees, among customers and suppliers. We have transaction processing systems, which handle things like sales and inventory management, while enterprise information systems integrate and manage processes across different departments. We have decision support systems, which provide access to data and analytical tools to support that decision making, and execution systems, which operate or automate operational activities like manufacturing and logistics. When it comes to who uses these information systems, these various information systems, it is really depending on the type of that system and the purpose of that system. Like office automation system, they can be used by anyone who needs to perform any kind of clerical task efficiently, whereas communication systems are used by employees or customers and suppliers to collaborate. Transaction processing systems are used by employees who handle business transactions, whereas enterprise information systems are used by the different departments within an organization. Decision support systems, again, they are used by employees who need access to the data for decision making, whereas execution systems are used to automate the operational activities. Now let us talk about organizational change. One of the common forms of change is definitely automation, where information technology is used to make tasks more efficient. This could be anything from calculating paychecks to developing a nationwide network of airline reservation terminals. It could be anything. So that is one form of change. Another form of change is business re-engineering, where businesses' processes are radically redesigned to reduce the cost and improve efficiency. This is like overhauling the engine of a race car to make it faster and more fuel efficient. So these are two of the major changes an organization could have when it comes to on the basis of their information systems. Finally, let us touch on outsourcing. Okay, this is something which most organizations do. In one form or the other, they definitely outsource. This can be a very valuable tool for organizations, especially when they lack the expertise or the resources to handle certain information system applications. However, it is important to understand the disadvantages and manage the process properly to ensure that value is obtained. Outsourcing means you are you are giving the responsibility of managing certain things to an outside agency. Okay, that is called outsourcing. So these outsourcing decisions should be based on a thorough assessment of the organization's needs and capabilities. Like for example, we saw earlier when we were talking about building information systems, we saw that we can either build it in-house with our resources, or we can tell it to somebody else to build it for us. Telling someone else to build it or manage is nothing but outsourcing. Or we can purchase something off the shelf. So these are the three ways in which we saw we can build information systems, right? So if we decide to build something in-house, then we'll have to hire people who have that knowledge, and we have to set up all the servers and machines and things like that, the development environment and a lot of things. So it becomes a lot of work for us. So those many skilled employees we'll have to involve, right? But the thing is that cost, is it worth it? Like if suppose say it will take 1 crore rupees to develop a software from scratch, and I can get that same software, almost similar software, for 10 lakh rupees with minor tweaks here and there. I can get it for 10 lakh rupees if I'm outsourcing that development to somebody else. Then what will I do? I'll definitely outsource, correct? So that is called outsourcing. So in conclusion, information systems are critical components of modern businesses, and understanding their resources, the types, the users, and the impact on organizational change is key to harnessing their full potential. So the traditional system lifecycle is a structured approach which guides the development and maintenance of information systems. It is like a roadmap which helps teams navigate through the various phases, ensuring that each step is completed thoroughly before moving on to the next. Let us break down these 4 phases of the traditional systems lifecycle and see how they work together. Initiation is where it all begins. During the initiation phase, the problem gets identified and the feasibility of developing the solution is assessed. Users play a critical role here, helping to define the problem and how the information system should address it. You can think of it as laying the foundation for the entire project. And once this problem is defined, it is time to analyze it in detail. The analysis phase is where the causes of the problem are identified and potential solutions are specified. Information requirements are also identified during this phase. Feasibility studies are conducted to determine if the proposed system is technically, economically, and organizationally feasible. With a clear understanding of the problem and its requirements, now we can design the solution. That is the third phase. This phase involves creating a logical design of the system, which specifies what the system will do, without focusing on how it will be implemented physically. So this includes system flowcharts or data flow diagrams and process specifications. User involvement is again crucial here to ensure that the system will meet the needs and expectations. Now comes the nitty-gritty part of building the system, that is development. The development phase is where the logical design is translated into physical design, including the database design, program specifications, and system documentation. The system is developed and tested thoroughly to ensure that it will function as intended. Again, here also user involvement is very much essential during the testing to identify if there are any issues and make sure that the system we are developing is usable. The last, not the last, you can say, the next after the design phase, it is time to put the system onto action. That is the implementation phase. Here the system is installed and users are trained on how to use it effectively. Documentation and support materials are provided to help users navigate the new system smoothly. User involvement again here also continues to be important to address any concerns or issues that may arise. The last step is operations and maintenance. Once the system is up and running, it has to be maintained to ensure continued functionality. And this operations and maintenance phase is where it is ensured. It involves ongoing support, updates, and enhancements to the user system. User feedback is again valuable to identify areas of improvement and making necessary adjustments. So throughout this traditional system lifecycle or this software development lifecycle, user involvement is emphasized to ensure that the system meets their needs and expectations. Each phase builds upon the conclusions of the previous one, ensuring a systematic approach to system development and maintenance. So while the process is tightly controlled to minimize mistakes, some activities may be completed in parallel and phases may be repeated iteratively until a satisfactory system is achieved. Now let us go on to the programming languages. Okay, programming languages serve as a foundation for creating computer programs that perform various tasks. Identifiers, constants, expressions, library functions, these are all fundamental concepts of components of programming languages which helps developers write efficient and functional codes. Okay, so what is this identifier? Identifiers are names that are assigned to program elements like variables. What are variables now? Okay, so the thing is, see, what you can say for example, there is a person. Okay, there is a person. That person's name, depending upon who, so this is a box for person. Okay, so depending upon which person stands over here, the age, the name, the ethnicity, all these things are going to vary, right? So this person is a variable. Why? Because see, suppose say I am creating a program which is going to calculate the age of a person. Okay, so how, as of today, so how will I do that? I will do that by I will calculate the current date and I will minus it, and I'll minus his date of birth, so her date of birth, and I'll get the age, right? So this date of birth is a variable, right? It could be anything. My date of birth, if I am the one who's entering my date of birth, if you are entering your date of birth, it is going to be varying, right? My date of birth need not be your date of birth. So this is a variable. It varies. So, but this current date, this is also a variable. Why? Because if I am calculating today versus if I am calculating tomorrow, it is going to be different, right? So these are variables which vary. But at the same time, speed of light, it is a constant. It is not going to vary, right? Similarly, the gravitational pull of Earth, the value of pi, these are all constants. They do not vary. Now, this date of birth or birth date, sorry, DOB, right? Not B. Okay, DOB, date of birth. Okay, so I will have this variable. It is called date of birth. This is an identifier. This DOB is the identifier, helping us identify that variable called date of birth. Okay, so that is identifier, constants, and variables. Now let us look at expressions. Then what? Yeah, so we saw about, now we have to look at expressions. Expressions represent single data elements or single data items like variables or arrays or references to functions. They can involve a combination of these entries also. Like for example, say sum is equal to a plus b. Okay, this is an expression. So it is a combination of variables joined by operators. So this is an expression. Library functions are pre-written functions provided by programming languages to perform common tasks, like for example mathematical calculations or string manipulation and things like that. So one easy example is, suppose say I have a long sentence, like for example, so let us take this: user friendly, supports object oriented programming. This is a sample string. Okay, string means a long string. String is nothing but what is a string in common sense? A string of pearls, a string of flowers, right? A mala, right? String is that only. So this is a string of characters. Now if I want to split, if I want to extract or split only the words, so user friendly is one word, supports is another word, object oriented is another word, or say for example in this sentence, key is one word, components is another word. So how can I extract it? We have to split the sentence on, if I split the sentence at every space, everywhere I see a space, if I split it, I'll get the words alone, right? So that split, actually, how do I tell this computer, or how do I tell the computer to split it in the using a programming language, right? So for that, simply, so depending upon the language, the programming language, each language will have a slightly different variation of that, for that, but there are inbuilt functions. Say for example in Python it is split. So if I say in Python, if I say split and I give the variable name where the string is, so where that line is saved, if I say like this, Python will tell the computer to split it at every space, right? And we will get the list of words. So this is a basic example. Okay, this is just for people who do not know computing or programming, just for your sake, for your understanding. So this split over here is a library function. It is a pre-written function that is provided by Python or that so and so programming language to perform this task. Okay, so this can be called upon by developers to perform specific tasks effectively. So now let us look at a few of the common programming languages. Few of them only we need to study. There are many languages, not everything we are studying, but just a common few we just need to know, so that you guys are aware of the available programming languages, right? We have Visual Basic, VB.NET. It is a prominent programming language which is known for its versatility and user-friendly features, making it an excellent choice for software development. So Visual Basic is visual software. It has the visual elements, like you can create buttons and things like that, and with the click of each button, what all things should happen, it is created like that. Most in Excel also there is a tab for Visual Basic, macro creations and all, right? It is a very popular language which is which is having wide applications. So some of the reasons why this Visual Basic.NET is highly regarded is because of its object-oriented programming nature. It supports object-oriented programming and therefore allows developers to create reusable codes and build complex applications with ease. Similarly, there is ease of learning. It is based on basic programming language. It is very relatively easy to learn. Therefore, it is suitable for beginners as well as experienced developers alike. So we have structured languages. VB.NET provides a very clear and organized way of writing code, facilitating readability as well as maintenance. Then we have modular programming. It supports modular programming approach, meaning it helps developers break down large programs into smaller, more manageable components. Applications that are developed using VB.NET can be run on various platforms, therefore enhancing their versatility and accessibility. It also offers a wide range of data types and control statements, empowering developers to create robust and efficient programs. Whereas there is another program, Java, which is often hailed as a true object-oriented language due to its extensive use of objects and classes. Some even argue that it may not be entirely pure because it supports primitive data types like int, boolean and all, which are not objects. Nonetheless, Java's robust support for this object-oriented programming principles like encapsulation, inheritance and all makes it a powerful language for developing complex applications. Now, many of you, I'm sure, if you are not having any kind of science or computer science related background, these terms might go on top of your head. It is fine. You just need to know about what is Java, what is Visual Basic, what is HTML, what is Excel. Okay, just the basic stuff. You just need to know that there are these kind of things. Okay, it is robust, it is an object oriented support. What is encapsulation or what is inheritance, you need not know. Okay, this is absolutely fine. You need not know. Nobody is going to test you on what do you mean by encapsulation. Explain for 20 marks is not going to come for MBA, because that is, we are MBA students. We are not BCA or MCA students. They should know, but not us. Okay. So don't worry a lot about trying to understand what is encapsulation or what is inheritance and all. Just leave it. You just need to know about these languages. Like there is Visual Basic.NET, which is user friendly. Okay, there is Java, which is object has very powerful features. Then we have HTML, that is hypertext markup language. Any website that you see is made up of HTML code. Without HTML you cannot have a website, right? It is a markup language which is used to create web pages by structuring contents like headings, paragraphs, and multimedia elements like images or videos. It defines documents in a way that any browser on any computer can read and display them, making it a very accessible and widely used program on the net. Similarly, we have Excel. We have all used Excel. It is, on the other hand, a very versatile spreadsheet package commonly used for financial analysis as well as reporting. It allows users to perform various mathematical operations, create financial reports, and visualize data through graphs and charts, making it an indispensable tool for accountants and finance professionals. So overall, what you need to understand is that programming languages like VB.NET or Java, along with these markup languages like HTML, serves as essential tools for developers and professionals in various fields, enabling them to create functional software solutions and web applications to meet diverse needs and requirements. So the next time you are thinking about building a software, all you have to understand for your day-to-day operations also is that you have to think about the programming language in which it is written to. Because some programming languages you will find skilled professionals quite easily, like Java being a very old language by now has a lot of skilled people available, whereas a very newer language like say Scala and things like that, Scala is not exactly new, but still it might be difficult for you guys to find good enough resources. So and similarly, if you are creating a web page, then you must know that your people, whoever is you are hiring, will be talking about HTML based stuff, right? So this is what from an MBA, from a managerial perspective, you need to understand. You do not need to go into the nitty gritty of what is an expression or what is a flow chart or what is a inbuilt function, what is a lambda function or what is encapsulation, nothing like that. Okay, polymorphism, there are a lot of many terms, many technical terms. You need not go into the depth of any of this, but you need to have a basic understanding about, when you hear a term, at least it should ring a bell somewhere. Okay, so that was about programming languages. Now I want you guys to imagine that you're browsing the internet, okay, searching for information on any topic, your favorite topic, and you come across a website with a list of numbers, okay, all digits lined up. Okay, so or you can say, imagine, instead of me giving this English like readable data, if I'm just writing 10111110001111 like this, I'm filling the page. Okay, that is data. That is pure machine understandable data. That is machine's language, right? So it's very difficult for you, right? It is like finding puzzle pieces that are scattered around. They does not mean anything for you, right? But, or let's say, rather than 0 1 1 1 1 1, let's say it is scattered like this: 5 10 15 20 25, like this. Okay, it's just written like this. This is not machine code, right? This is also data, but again, this also does not mean anything on their own. But what if I draw a graph and I write 5 10 15 20 25 like this? If I plot it on a graph, then that might mean something depending upon what is in the x-axis and what is on the y-axis. Now suddenly these numbers which were scattered, which did not make any sense to us, became meaningful. That is, they have become information now. So now think about organizing this massive collection of data. Okay, it is like sorting out a very cluttered cupboard, and this is where databases come in. Okay, a database is a well organized cupboard where everything has its place. It is a collection of data that is structured and easy to access. But managing this database is not just about putting things in order. It is also about keeping everything running smoothly. And that is where this database management system, that is DBMS, comes into play. It is like having a cook or not cook, it is like having your own closet manager. I think maybe Ambani's will have cupboard manager, right? Making sure that everything is where it should be and handling requests to find or update items. So who is in charge of all this well-organized cupboard? It is this well-organized database. It is the database administrator, the DBA. They are the ones who keep everything in check, making sure that the data is secure, it is updated and is performing at its best. You can think of them as the guardians of your database galaxy, right? They ensure that only authorized users can access your data and everything is in its right place. So now let us talk about how we organize the data in our database. That is where the data models come in. Think of them as blueprints for how we arrange our data. We will start with a conceptual model, a very high-level overview of what our data will look like and how it will be organized. And then we will get into the nitty-gritty with the logical model, defining the structure of our data in detail. And finally, we will have the physical model, which will tell us how our data will be stored in the database. But what happens when our database gets cluttered? That is where normalization comes in. It is like tidying up our database and getting rid of all the duplicate items and making sure everything is organized efficiently. So we go through different normal forms, each of them refining the organization of our data until it is as streamlined as possible. Now, let us talk about the latest trends in this database technology. We have come a very long way from just storing texts or numbers. Now, databases can handle all sorts of data types, from images and audio to complex objects with multiple properties. We can even store our speech, right? We have this object-oriented databases which treat each piece of data as an object with its own properties and methods. Then there are object-relational databases which combine the flexibility of this object-oriented programming with the power of relational databases. And let's not forget about the spatial databases which can handle geographic data like maps or coordinates, and multimedia databases which can store everything from images to videos. So in summary, databases are like well-organized cupboards for our data, which is managed by the database administrators and are structured using data models. Normalization is a way of keeping our data tidy, while advancements in technology allows us to store more and manipulate all sorts of data and data types. So the next time you are browsing the internet or organizing your cupboard, remember the parallels to the world of databases. Okay, I'm sure you will. Navigating the landscape of operational systems and their databases can be similar to steering through turbulent waters, especially when it comes to servicing the information needs of strategic decision making. So some of the practical challenges that are faced in this domain involve or include ad hoc request overload. That is, the information technology department, IT departments could often find themselves overwhelmed with this ad hoc request. Ad hoc meaning which has come immediately on the fly requests, leaving them grappling with limited resources and unable to respond promptly to all these various demands. So that is one challenge. Then ever-changing requests. Not only are these requests ad hoc and numerous, but they could also possess a chameleonic nature. That is, constantly it will keep on changing. So it is like you give one document to edit or one matter to edit, and then constantly you're coming and saying, hey, please add this also. Huh? Hey, please add that also. Huh? I need this this small thing also you add. Like that, you're keeping on updating them, means it is an ever-changing request. So users find themselves seeking more reports to elaborate on and understand the findings of their earlier requests. There is a spiral of supplementary requests. That is, users that are caught in a vortex of seeking more and more elucidation often resort to asking for every conceivable combination. So inadvertently, they are putting more and more burden on the IT resources. Similarly, over-dependency on IT. Users often find themselves reliant on IT to furnish the required information, lacking the means to access the data interactively on their own. So such hurdles render our operational systems ill-equipped to furnish the requisite information for strategic decision making. Let us now look at the crucial extract transform load, that is ETL process, which transforms this backbone of data warehousing. So the in ETL operation, extracting the data from various sources and transforms it into an analyzable format and then loads the data into the warehouse. This is the fundamental tenets of this ETL operation. So at the helm of this ETL process lies the load manager, who is tasked. Load manager is not a person, okay? It's a component only. It is a computer component only. It's titled the load manager. It is tasked with orchestrating the entire operation. Database administrator was a person, okay? It is usually a person, but this load manager is not a person. It retrieves data from diverse sources like operational databases and external repositories and meticulously transforms it into an analyzable format before ushering it to the data warehouse. So what are the functions of this load manager? This pivotal component performs a triad of functions, that is data extraction, transformation and loading. In the extraction phase, the load manager gathers data from disparate sources and preps it for the metamorphosis that awaits. And what is that metamorphosis? Transformation. Transformation phase witnesses the application of an array of rules and algorithms to ensure that there is data accuracy and consistency. And finally, it culminates with the loading, in the seamless ingress of transformed data into the data warehouse. So in essence, this load manager stands as a sentinel, ensuring that the data within the warehouse remains pristine, clear, accurate, consistent and up to date, which is a prerequisite for sound business making, right? If the data that we have for making the making the decisions, if they are not clean, if they are not accurate, if they are wrong, our decisions will also be wrong, correct? So now let us tackle some of the terms and concepts from this realm of data warehousing. We need to know about subject orientation. So think of subject orientation as the organizational framework within a data warehouse. Here, data is structured and optimized by thematic categories like sales, marketing, finance, with each category housing specific subjects like products, customers, and regions. Then we have granularity. Granularity denotes the level of detail or summarization within the data warehouse. Higher granularity implies greater detail, while lower granularity indicates a more summarized view of the data. Aggregations. In the context of data warehousing, aggregations refer to the process of summarizing data to provide a higher level perspective. This helps in reducing the volume of data to be processed and facilitating a broader view of the data. Partitioning. Partitioning involves the division of large tables within the data warehouse into smaller, more manageable segments. And this can enhance the query performance and streamline data management. Time variancy. It underscores how data evolves over time. It incorporates a historical dimension to it, allowing for a temporal analysis. Temporal means over time, okay, and comparisons, and which is an indispensable aspect of data warehousing. So with these fundamental concepts at our disposal, we can now dive deeper into the nuances of data warehousing and its intricate mechanisms. I'm sure you will be able to much better understand the concepts that are written in data warehousing and mining. Now let us talk about the second last unit of our MMPC 8, that is Artificial Intelligence and Decision Support Systems. The Artificial Intelligence, AI. It is a buzzword these days, right? For anything and everything that is in AI, right? It is a marvel of modern technology which is aiming to replicate human intelligence in machines. Its inception was actually driven by the necessity to tackle complex problems that were beyond human capabilities alone, leveraging the power of skillfully coded real-world knowledge and rules. This development of AI actually traces back to the emergence of the first modern computers in the mid-20th century. and was inspired by Babbage's analytical engine. These early machines that were crafted from thermo-ionic valves laid the groundwork for all the cybernetics, alongside breakthroughs in language and information theories. And today, AI permeates nearly every scientific discipline, from speech recognition to natural language understanding, empowering systems to learn, to reason, and even advise autonomously. Its applications can span diverse domains from research and development to healthcare, industry, and beyond. And when we are integrating AI into organizational frameworks, we need to follow a systematic approach. So, what is the systematic approach? Let us look at it stepwise. So, the first step is to identify the problem. Pinpoint the specific areas where AI can augment your organization's performance. Gather the data. That is, assemble relevant, accurate, and comprehensive data sets to train those AI systems effectively. And choose the right AI technology. Select the AI technology tailored to your organization's needs, considering factors like problem complexity and resource availability, and develop the AI model. Design algorithms and system architectures aligned with the organizational objectives. And once you design it, once you develop it, train that AI model, feed the data into the system, and enable learning and refinement. Test your AI model, that is, assess the system's robustness and performance across various scenarios, and you can deploy the AI model, implement the system in the organizational workflows, and ensure seamless integration and functionality. But that is not enough. That is not the last step. You must always aim for continuous improvement. Monitor the system's performance and make necessary adjustments to enhance its efficiency over time. So within the realm of this AI, expert systems stand out as an exemplar of specialized domain knowledge application. Evolving from simple problem solvers to sophisticated decision-making tools, these expert systems boast predictive modeling powers and a permanent memory bank, facilitating informed, consensus-driven decisions. I said earlier also what this expert systems were, right? It is the knowledge of many people, many experts in particular domains, all condensed or all coming together in a single system. Additionally, we also need to know about artificial neural networks, ANNs, and genetic algorithms, which harness the power of machine learning and evolutionary principles. ANNs excel, that is, artificial neural networks excel in pattern recognition and prediction, whereas genetic algorithms optimize solutions through a population-based evolutionary approach. We need to know about fuzzy logic, which introduces a nuanced perspective, accommodating uncertainty and incompleteness in data analysis. Its applications span speech recognition, automated reasoning, and beyond, offering a potential tool for navigating complex decision-making landscapes. In essence, AI represents a very transformative force, reshaping industries and empowering our organizations with unprecedented insights and capabilities. And as we harness its potential, a strategic, methodological approach should be there from us managers so as to ensure maximum value realization, propelling us into a future that is brimming with possibilities. So, have you ever thought about how information and communication are like two peas in a pod? Hmm? Like how this information is related with communication? The fact is they are more than just related. Okay, they are practically actually inseparable. You cannot separate information from communication. When we say that information and communication are complementary, it is like saying that they are a match made in heaven. Think about it. You need information to communicate effectively, correct? Whether it is sharing news about a new product or in a business meeting, or you are just chatting with your friend, or if I am chatting with you, I am making a video. If I have to communicate to you, I need to have information, right? Similarly, vice versa is also true. Communication is essential for sharing information, right? So say, for example, I'm trying to convey you a very important idea, but I cannot speak, I cannot write, or I cannot even guess. I cannot even show you sign language. Can I communicate? It's going to be very tough, correct? So, but here is where it actually gets interesting. Communication just doesn't go hand in hand with information, but sometimes it takes up a notch and becomes supplementary to it. That means it adds that extra oomph, making the information even more valuable or easy to understand. Take a presentation, for example, right? Take this presentation, for example. I know this is quite boring, right? I've just listed out some facts and figures, but if you look at my detailed video on MMPC 8 topics, there I have put a lot more interactive elements, right? Some visuals, small animations, right? Then it becomes more interesting. Now simply I'm saying something like, there are a lot of IGNOR related classes, right, where they just read and read and read from your textbook. Is that making any sense to you? Why doesn't those videos work when we are coming to study, or when we are trying to figure out what is there in this unit, or from what is there in this particular course? Why that doesn't work? Why does that go why does that make us sleepy? Because there is no engagement, there is no humor. The reason why sometimes I ask you about certain things, like comment this, comment that and all, or I share my stories with you, why is it? Because suddenly when I'm sharing such experiences with you, you are more engaged, right? And that way, maybe sometimes, for some of you at least, the things that I'm trying to tell you, or the information that I'm trying to pass on to you, sticks with you much better. Like I've got a lot of comments from my previous classmates that they could hear my voice saying to them, speaking to them in examinations. That is what you can say, that is one of the greatest honors any teaching staff or any facilitator could get. I'm deeply honored by those comments, by those experiences that you share with me, and that is what is helping me also to, every day, every night I think about how best to give you what better could I share with you, how could I make your learning journey easier. Every waking moment, every sleeping moment, I think about that. How can I better serve you guys? How can I make it easier for you, right? So that, when I think like that, and when those kind of presentations, the information sticks better with you, right? So that is why I'm saying sometimes information and communication become supplementary to each other. Now let us switch gears a bit and let us talk about the competitiveness of information and communication technology, right? ICT. Essentially, this is all about how well a country can jump into the economic game of using technology, this ICT. For developing nations especially, this ICT, information communication technology, can be a game changer by opening up doors for more manufacturing, or more jobs, and more overall social development. So it is like having a secret weapon. Okay, the better you are using it, better you are at using it, the more competitive you can become in the global market. And speaking of technology, how many of you have noticed how everything seems to be converging these days? Right? We used to have separate gadgets for everything, right? We used to have computers for computing stuff. We used to have phones for calling, TVs for watching television, right? But now everything is merging into one super device, right? We can see TVs, we can call, we can video call, we can watch movies, we can compute, we can even run. When I used to teach Python, I used to tell students, you don't have to bring a computer or anything. If you have your mobile phone with you, if it is a smartphone, you can learn Python from there itself, right? So everything is becoming one, right? So everything is converging into one super device. Now everything can do everything. Even TVs can call these days, smart TVs, correct? So this convergence trend is reshaping our industries and pushing companies to become more versatile, and it is blurring the lines between hardware and software. Let's not forget about wireless technology also. When we are talking about emerging trends in IT, we should not forget about the wireless technology. That is everywhere, right? From our homes to our workspace, having seamless connection is becoming the norm here. If there is no Wi-Fi, like even now when we are going to somewhere, say a hospital, if they're not providing free Wi-Fi, we're like, what? Like, what is this place? Why can't they just provide free Wi-Fi? I know you guys have Wi-Fi here, right? It's becoming a norm. Even railway stations have free Wi-Fi then, right? Signal processing, broadband, you name it. They are all parts of this puzzle, which is making our lives more and more connected and convenient. Now, let us talk about e-commerce. In emerging trends in IT, we should also talk about this very important e-commerce. It is not just about buying or selling online anymore, but it is a whole experience these days with wireless internet, which virtual assistants, and even augmented reality, right? Even Amazon lets you see how a particular piece of furniture will feel like in your space by using your own phone's camera, correct? So augmented reality, lens card, you can see how the frame actually feels like in your face. Tanishq's site, have you seen? You can actually see those earrings or those necklaces, how it will feel like on you. All you need to have is a smartphone with a decent front cam, and you need to have good lighting. So preferably if you want to use it on when there is ample daylight, correct? So shopping has never been more immersive than this, right? It is going to get more and more immersive, but for as of now, compared to the earlier days, it is becoming very immersive. You can do everything right from your home at any time that you want, right? But with all these cool features, there is a big question. How do we balance this convenience with privacy? Right? That is a hot topic, and one that businesses are actually grappling with as they are trying to collect data without crossing any lines. Right? So that is one important aspect here. We should think about the privacy aspect of it. Then there is blockchain, cryptocurrency. These are, like, you can say, new kids on the block, right? New people, newcomers. Blockchain is a very super secure digital ledger that is perfect for recording transactions and keeping things very transparent. Cryptocurrency is like the digital money that's decentralized and super safe. And together they are shaking up the finance world and beyond, and are offering a very new way to do businesses. But they are all catching up. They are becoming a thing, but they are still not yet the thing, right? Last but not least, when we are talking about emerging trends in IT, we should talk about machine learning and data analytics. These are like the brains behind the operation of all these things, right? Using algorithms, statistical models to crunch numbers and make sense of all that data that is floating around. From predicting trends to analyzing patterns, they are the secret sauce. This ML is the secret source that helps businesses stay ahead of the game. So whether it is information and communication working hand in hand, or the latest tech trends that are shaping our world, one thing is for sure: the future is definitely looking pretty exciting, isn't it? So as managers, you should all be very, very, very much ready to embrace all this new technology by the time you actually get into managing, correct? So with that, we have covered all the major aspects of information systems for managers as it is stipulated in MMPC 8 of your IGNO MBA's new syllabus. If you are totally new into the world of communication technology, then please do not worry. I have a course. I have this MMPC 8 detailed course in the channel. It is there for you to watch. Every unit has been expanded upon more elaborately, right? So this was a condensed overview. This was a rapid roundup. I have just touched upon the major concepts here and there, right? But there you will find everything in depth. Okay. So thank you so much for tuning into Anu's Classroom. I hope you have already subscribed to the channel and enabled the notifications. If not, please, it's a humble request from my end. Please do so. And let us catch up in the next session. Thank you so much. Bye-bye.